Hello and welcome. I'm Pravir, and in this session, I'm going to focus on rethinking the connection between quantum computing and AI. This is going to be structured in the following way. I'm going to begin with a challenge posed by Dr. Richard Feynman in the 1980s. I'm going to then suggest an alternative or a different trajectory of development for quantum computation and its connection with AI than what's being pursued by the quantum computing industry today. So I'll begin with this idea of the underappreciated quantum computer, speak about some of the output of this quantum computer, which is genetic type output, and then delve on the concept of the ubiquitous nexus before transitioning to some technological implications, and then I'll end with some parting questions. So in the 1980s, Dr. Richard Feynman, a physicist, saw limitations with the contemporary computational approaches if they were to simulate nature, which is quantum mechanical. And he summarized this by this quote: nature is in classical, damn it. And if you want to make a simulation of nature, you'd better make it quantum mechanical. And by golly, it's a wonderful problem because it doesn't look so easy. And here, I want to draw attention to this sea change that occurred in the idea of computation in the following decades. And this required deep insight to actually generate this. Now, the industry has pursued a certain trajectory of development, and I'm not going to focus on that. But I want to draw attention to another possibility over here. And in drawing attention to this, it will also cause us to rethink the connection between quantum and AI. So I'll begin with this idea of the underappreciated quantum computer. And here, what I'm speaking about is an atom. So why would I call this the underappreciated quantum computer? Primarily because if we think about an atom, we know it's comprised of quantum particles. We have nuclei that are made from quarks and bonded together through the action of bosons. So quarks and bosons both being quantum particles. We have electrons, another type of quantum particle that we know exist in stable orbits around the nucleus. And we also know that these electrons may exist in multiple superposed states. So it's exhibiting this quantum mechanical property of superposition. We also know that all atoms that share the same atomic number exhibit the same properties regardless of where they may be. And I'd argue that that's an instance of entanglement. And we also know that the lifetime of these states, superposition, entanglement, endure, in contrast to some of the difficulties we're running into with developing quantum computers right now. We know that this atom is a stable entity, but also it's in a continual state of change due to interaction with or releasing with photons. So we can think about an input into this quantum computational device or mechanism being photons. Due to that, the state of atom changes, and then there's an output of photons, or in some cases, electrons. And so, in other words, the atom is subject to persistent dynamics of quantum computation. And at the same time, it remains entirely stable. So we know that atoms operate robustly in a range of environments. We also know that atoms are completely stable because we have the proof of that with molecules, with molecular chains, with cells that are all essentially created by connecting trillions of atoms together. So the question is, if the atom is a naturally occurring quantum computer, then what's it computing? And I want to suggest that what's it computing can be thought of as genetic type code. So if we take the example of an atom with the atomic number of 47, silver, we know that it'll maintain its behavior regardless of where it exists. So we can expect these atoms to have behaviors like ductility, malleability, superconductivity, non-corrosiveness, and so on. And I want to suggest that this is due to some kind of code that is accompanying that atom, and that, in a sense, is binding the atom to a certain set of behaviors and a particular way of operating in the universe. So this code, if it exists, can be thought of as pre-genetic code that essentially is fulfilling the same purpose as a genetic code in cells. So if this is true, then what are other instances of naturally occurring quantum computers? As I suggested, we have molecules that are comprised of atoms, and therefore they must be even more sophisticated quantum computers. And then we have molecular plants such as lipids, proteins, polysaccharides, nucleic acids that are chains of molecules, and that would imply that it's even more sophisticated instance of quantum computers. And then we have cells that comprise these four molecular plants. And so these become an even more sophisticated type of quantum computers. So just to step back and ask, what are cells computing? How are they computing? And we know that there's native genetic code, and by computing as per that genetic code, a cell is able to maintain its integrity, possibilities, and boundaries. And if there's a threat to that, then there's new code that's generated. And so from this point of view, the cell can also be thought of as a sophisticated quantum computer. Now, I want to draw attention to this idea of ubiquitous nexus of quantum computation and intelligence. And here, if we step back and look at this phenomena of quantum particles becoming atoms, atoms becoming molecules, molecules becoming molecular plants, then it appears that intelligence is continually codified and upheld by a series of naturally surfacing and progressively more sophisticated quantum computers. So what's the implication of this? If this is true, what is the implication of this? It implies that there may be some repository of quantum intelligence natively at the quantum levels. And in this point of view, then intelligence could be a fundamental property at the quantum level. And the surfacing of more complex natural quantum computers can be thought of as allowing more of this intelligence to materialize. So in the cell, we have much more sophisticated set of rules or intelligence that dictate how it operates and how it adapts as compared with, say, an atom or molecules. And then the question is, how would AI compare, if QI or quantum intelligence is true, how would AI compare with QI? So AI is conceived, leverages a subset of conceptual mechanisms that derive from human intelligence. However, due to the huge ability of the processing power and the large data, we see extraordinary applications of it. But the fact remains that human intelligence can be thought of as an outcome computed into existence and housed in a human being that's based on this native quantum intelligence. And so any kind of AI is going to be derived from that subset of quantum intelligence that shows itself in AI. And so by definition, then, quantum intelligence could possibly be vastly more intelligent than all instances of intelligence that arise from it, no matter how extraordinary or spectacular things look. But there's this other possibility that there's just a huge reservoir of untapped intelligence that has yet to surface, and perhaps also, depending on how we interact with that layer, would begin to surface and have a plethora of different kinds of applications that we can't even conceive of right now. And here I want to draw attention to an interesting quote by Werner Heisenberg, the a Nobel laureate and the inspiration behind the Heisenberg uncertainty principle. Where he says the first gulp from the glass of natural sciences will turn you into an atheist, but at the bottom of the glass, God is waiting for you. And the way I read this is that there's just an infinite more possibility as you penetrate into that depth, which is what is being suggested by this idea of the nexus between quantum computation and intelligence. So, so far, what we've done is we've looked at atoms as this ubiquitous and underappreciated quantum computer. And here there's an interesting quote by Dr. Richard Feynman. There is nothing that living things do that cannot be understood from the point of view that they are made of atoms acting according to the laws of physics. Of course, the idea here is that we have atoms that are endowed with something more than a physical study of them have surfaced. And also is the idea that the laws of physics are of a particular type right now, but as we continue to advance, even these laws of physics will prove to be a subset of what we uncover over time. And if you take this quote from that point of view, then what you have is the idea that there is nothing that living things do that cannot be understood from the point of view of atoms. Now, transitioning to some technological implications, I want to pose the idea of nano-based devices that, because they are built leveraging atoms as a natural quantum computer, and because we've posed this idea that these natural quantum computers are generating genetic type code that lies at the bottom of modern, more sophisticated manifestations of matter and life, access at that level or rethinking atoms and molecules at that in this way would provide revolutionary access to the generation of materials and changing the foundations of material sciences. And this is due to being able to affect atoms and molecules and the genetic type code they generate from the bottom up. So differently than we're doing it right now. It's not just about simulating the actions, but it's about realizing that there's some behaviors and some possibilities that also exist that are not in our purview of simulating things at the moment. Similarly, this would also provide revolutionary access to the management and maintenance of life. And again, this is due to affecting molecular plans in cells and the genetic code they generate from the bottom up, as opposed to intervening from the top down or by, say, medically diagnosing from the top down based on instrumentation and models that we have. This would be the management and maintenance from the bottom up. I also want to suggest that these nano-based devices would potentially be able to facilitate emergence of other forms of intelligence that may exist at the quantum levels. So if we were to create, say, a device that could interface with the organicness of the quantum level, perceive what's happening there differently, then we may be able to get another form of intelligence surfacing as well. In work I've done, I've suggested that if we look at layers of matter and life, we see a common fourfold pattern that animates, for example, quantum particles, a layer of quantum particles, a layer of atoms, a layer of molecular plans. And this is suggesting that there's, if you reverse extrapolate, that there's something fundamentally different that we haven't modeled yet that also exists at the quantum levels. And it has something to do with the pattern that is fractally emerging. And there's a root space-time energy gravity pattern that, if harnessed, can bring about a revolution in a couple of areas. First of all, it could potentially provide us an inexhaustible source of energy because, as we know, there's an infinite amount of energy, or a very vast amount of energy, in atoms. E equal to mc squared already proves that. We know there's even more energy in molecules bound together, and we know that cells have an even higher level of energy. But the idea here is that there's a common pattern that connects this all together. And by perceiving that, we could begin to manipulate the source of these patterns in a way that would give us access to a much larger source of energy. And I also want to suggest that since this is a ubiquitous nexus, this thing is available everywhere. Beyond terrestrial users, it can also be leveraged for extended space travel. So what I call these IQCI nanocyborgs, which is the integrated quantum computing intelligence nanocyborgs, so cyborg because it's organic and also it's mechatronic. These kinds of nano-based devices will allow deeper interaction with quantum properties beyond superposition, entanglement, tunneling, and annealing, which are the known quantum mechanical properties at the moment. And these properties, for example, I referred to briefly here quantum intelligence, fourfoldness, and others to be discovered. But the point is that we would have access to this, and that would be the source of other technological developments as well. Now, these IQCI nano-based devices would potentially also be able to generate quantum patterns, thereby allowing us to co-create in partnership with that underlying quantum intelligence. And these are concepts that seem far away, but if you view the quantum level in the way that I'm suggesting here, then they're not so far as it may seem. And it's also in learning to perceive, manipulate, and leverage these that extraordinary quantum intelligence-enabled technological possibilities will surface. And again, this is beyond the scope of the discussion, but I want to draw attention to a quote by Dr. Richard Feynman: "There's plenty of room at the bottom." So no matter how far we penetrate, no matter how much we think we understand the quantum levels, the fact is that the quantum layer separates the invisible from the visible, and there'll always be more possibilities that we'll begin to understand with time, and that's going to always be the source of continual technological development. Now, here's a quick snapshot of an IQCI nano-based device that I've designed, and the quick math. So these are extracts from a non-provisional patent that I've filed for, and I just wanted to give you a sense that this is something that can be practically created. And so I want to end now with some parting questions. So what is an atom? An atom, as I've suggested, is a ubiquitous quantum computing device that is underappreciated. What is it generating? It's generating genetic type code. It's upholding or it's computing by this genetic type code that exists, and perhaps even generating new ones once we learn how to leverage it. What is animate and inanimate matter made from? From this point of view, anything that's animate or inanimate, made from atoms, are all therefore made from this native quantum computational device. And what's the difference between AI and QI? AI, from this point of view, is a child of human intelligence, no matter how spectacular it looks. But human intelligence itself is a subset of quantum intelligence. And therefore, there's other possibilities that I'm suggesting exist at the quantum level that would perhaps create, if we don't leverage it, create something extraordinarily different than even what we remain fascinated by with AI at the moment. And what are some technological implications? Some technological implications is that it would, perceiving atoms, molecules, molecular plans, cells as computing devices and being able to interface with them in the right way would provide bottom-up access, at the very least, to create different kinds of, or influence material sciences, medical technology in radically different ways, beyond also, say, tapping into an inexhaustible source of energy, utilizing that for terrestrial use and for many different extended uses through space and so on. I want to end with this quote by Dr. Richard Feynman. We are at the very beginning of time for the human race. It is not unreasonable to grapple with problems, but there are tens of thousands of years in the future. Our responsibility is to do what we can, learn what we can, improve the solutions, and pass them on. Thank you.